PSA Certified is committed to creating a foundation of trust for all connected devices and making it as easy as possible to prevent simple IoT attacks. To achieve this, the PSA Security Model document, containing 10 goals, was devised to guide security best practices and provide a practical checklist to follow. PSA Certified takes a holistic view of security, considering both hardware and software security. The 10 security goals are in PSA Certified's DNA and inform the whole security framework and evaluation scheme. Let's take a brief look at the 10 security goals. More information on them is provided later on in this course. So it starts with unique identification. We need a mechanism to authenticate every device connected over the IoT network, starting with device identification. Hence, the need for a unique identification requirement for every device. A unique identity should be assigned to the device to interact with other devices, and this unique identifier assigned to the device should be attestable. This identity facilitates trusted interaction with the device, for example, exchanging data and managing the device post-identification and authorization. Devices should also support the security lifecycle that depends upon software versions, runtime status, hardware configuration, debug port status, and the product lifecycle phase. Each security state of the security lifecycle should be attestable and may impact access to the device. Attestation is the evidence of the device's properties, including the device's identity and lifecycle security state. The device identification and attestation data should be part of the trusted third party's device verification process. To ensure only authorized software can be executed on a device, secure boot and secure loading processes are required. Unauthorized boot code should be detected and prevented. Secure updates are required to provide security or feature updates to devices. Only authentic and legitimate firmware should be updated on the device. Authentication may be performed at the time of download. However, the execution of the update must be authorized via secure boot. Preventing rollback to previous software versions is essential to ensure that older versions of the code can't be reinstated once the latest software is available. Ensure the device executes only the latest updates or latest code, as the later version may fix known bugs. Rollback should be possible for recovery purposes only when authorized. Isolation aims to prevent one service from compromising other services by isolating trusted services from one another, from less trusted services and untrusted services. Devices should support interaction over isolation boundaries to enable the isolated services to be functional. The interfaces must not allow the system to be compromised. It may be required to keep the data confidential. Interaction should be considered both within the device and between the device and the outside world. To prevent private data from being cloned or revealed outside the trusted service or device, it must be uniquely bound to them. Confidentiality and integrity of private data are typically achieved using keys, which themselves need to be bound to the device and service. And lastly, we have cryptographic or trusted services. A minimal set of trusted services and cryptographic operations should be implemented as a trusted device's building blocks. These enable critical support functions, including security lifecycle, isolation, secure storage, attestation, secure boot, and secure loading.